All right, we're back. We're taking a pause from Chapter 2 material to review factoring, which some of you may know, some of you might not know, but we need it for Lesson 2-3. So if hopefully, let's think about the number 12. If I told you to find the factors of 12, hopefully you would remember that you could write 3 times 4. You could write 6 times 2. We could also write 12 times 1, right? Those are our factors of 12. So factoring an expression is much like factoring a number. You're breaking it up into its smaller parts that when you multiply them gives you this expression, right? And so in one of our last videos, we did something like this where you had x plus 1 squared and you had to expand it by actually multiplying x plus 1 twice. And you can see that gave us an expression in standard form, ax squared plus bx plus c. So whenever we factor something that's in this standard form, you're going to end up with two expressions like this, x plus or minus a number times x plus or minus a number, right? So I know, I'm just going to write that over here. When you're factoring quadratics, you're going to really end up with two expressions like this, x plus or minus some number and x plus or minus some other number. So let's multiply these out. Let's multiply just with pluses for right now. So let's say I had these two. What would I end up with? Well, I would end up with x times x is x squared. X times b, that's bx. A times x, that's ax. And then plus a times b. So then I could, hopefully you're okay with me rewriting it like this. B plus a times x plus ab. All I did was take those x's out, right? So that I can show you something. So why am I showing you this? Because whatever you figure out here, the product of a, b, in our case has to equal whatever c is, which in our case is 12. So this has to equal 12. Where the sum of a plus b has to give you the coefficient b, which in our case is 7. So that's how it helps you narrow them down, okay? And one thing I'm going to point out is that I chose to go with two positives here because I only have pluses in this expression. Sometimes there's negatives and you have to figure out which one should be minus, but in this case they're all positives, right? So I'm going to deal with only pluses. So let's think about 12. Well, I already know if the product has to be 12, there's only 3 things I can multiply. 12 times 1, 3 times 4, and 6 times 2. So then I go, well, which is the set of numbers that's going to give me a sum of 7? Well, if I look at those, hopefully you can see right away that 3 times 4 is the only one that's going to give me, the 3 and the 4 are the only one that's going to add up to 7. So if I were to factor this, it would be x plus 3 times x plus 4. And then we can check it. Let's check. X times x is x squared. X times 4 is plus 4x. 3 times x is plus 3x. And then 3 times 4 is 12. Combine those. Yep, it matches. So we know we are correct. We've just factored that expression. Okay, let's try this one. Again, all positives, so I know I'm dealing with this. So I know that in my case, a times b has to give me 9, and a plus b has to give me 10. So I start thinking, what can I break 9 down into? Well, 3 times 3, well, that doesn't give me 10. That's not going to work. But also 9 times 1. 9 and 1 are definitely going to give me 10. So therefore, when I factor this, I'm pretty sure it's that. And if you can't, you can quickly do it in your head. Or if you need to write it down, you could check x times x, x squared. X times 1 is x. 9 times x is 9x. 9 times 1 is 9. So this comes out to x squared plus 10x plus 9, which is what we want it to be. So this is our factored form. So there are some rules that will help you remember what the different signs have to be, which is attached to this lesson. But really, you can start thinking about the numbers to figure it out. You don't need to remember all those rules. So now let's try another one. Let's try to factor one with some minuses in it. All right. So in this case, I still know that the product of a and b has to give me negative 10. And then when I add a and b, it has to give me negative 3. Okay, so now I'm dealing with negatives. So there's going to be different options here. Like, for example, I could do negative 10 times 1, or I could do negative 1 times 10. But I know those are not going to work because why? Because when I add those, either way, it doesn't give me negative 3. So those don't work. What else? I also have 5 and 2, right? So it can be negative 5 times 2 or negative 2 times 5. Those are my options for that. So if I add any of those, do they give me negative 3? Well, negative 2 plus 5, that's positive. No. So I'm going to cross these out. But negative 5 times plus 2 is going to give me that negative 3. So I have a feeling it's this. So let's try it. X minus 5, x plus 2. Is that the factored form? Let's check. X times x, x squared. X times plus 2 is positive 2x. Minus 5 times x is minus 5x. Minus 5 times positive 2 is minus 10. So that becomes, yep, it works out. So here, oops, I wrote plus, but I meant minus. Here is the factored form. We just checked it. So this little trick that I'm running off to the side will help, but also you'll start doing this in your head and you won't have to write it. All right, let's try this one. So this one's tricky in two ways. There's a plus and a minus, and there's a 4 here. So I have to deal with this 4, okay? So here's what I'm going to do. A times B has to equal, so remember A times B always equals C, it has to equal negative 21, right? Except we also have to put this 4 in there. So here, just go with me. Because this 4 is in the front, I know that A times B has to equal negative 21 times 4, which is what? Negative 84? Okay. And then A plus B has to give me 25. So that part doesn't change. So the only thing that's changing right now is that we have to put that A, the coefficient, in front of the x squared, the A, here. Why? Because it's 4 times A, right? So I have to put that there. So now I have to figure out what I can add, multiply to get 84. That will also give me a sum of 25. So initially, I start thinking, oh, it's going to be negative 21 times 4, because that's going to be giving me 25, but let's check. Negative 21 plus 4 is not going to give me 25. What if I go the other way? Negative 4 times 21. No, that's going to give me 17. So that doesn't work, even though it seems like it's going to work. What else can give me 84? Well, 2 times negative 42. But right away I can see that's not going to give me 25, right? It's going to give me 40. So what if I go to 3? 3 times 28. But let's make one of those, we need one of those to be negative because 84 is negative. So then I'm starting to think, but I want the sum to be positive, so I'm going to keep my 28 positive because it's bigger and make my 3 negative. So that looks like the winner right there, because 28 times negative 3 gives me negative 84, but also 28 plus negative 3 gives me this positive 25. So let's check. So here, actually I'm going to write this down first. So what we've just done is, I'm going to rewrite this here. Okay, what we've just done are found the factors that are going to give us this middle term, right? So we've just found that it's going to be 28x and 3x. So we've just found that this part, right? We've just essentially said we're going to do minus 3x plus 28x. These two give us this middle b term, right? But what we're going to do is we're going to group these. This is called factor by grouping. And I'm going to group, so I'm going to group this 4 with the 28 because they have a common factor. And I'm going to group 21 and 3 because they have common factors, okay? So let's rewrite it like this. And then, okay, So those are helping us get this part. It's called factor by grouping. So all I've done is move the 28 by the 4 and the -3 by the 21. So now I can think of these as two independent parts. I can factor this first part and factor the second part. So what I mean by that is these have a common factor of what? A 4 and an x. So if I take out 4 and an x, all that's left here in this first term is an x. And what's left in the second term is a +7. And then minus, in this one I can take out a -3. And what's left in the first term? An x. What's left in the second term is a +7. Why was that helpful? Because now hopefully you can see that I can even factor out the x plus 7. And what am I left with? 4x minus 3. So this is my factored form of 4x squared plus 25x minus 21. So this is like a little added step because you use these to group the middle, which then gives you the expanded form. But let's just check if this is right. X times 4x is 4x squared. X times -3 is -3x. 7 times 4x is plus 28x. And 7 times -3 is -21. Yeah, and these come out to plus 25x when we solve it, right? And hopefully you can see that what we wrote here was really this, right? We had to put this step in here to figure this out. Another thing that you will start to do is you'll just start playing with numbers. Like you'll start trying, if I put 2x times 2x, and you'll start to see this pattern in your head without having to do all this work. Okay? Let's do one more like this. Okay, so here I know that A times B has to equal 1, but also you have to include the 6 in here because that's in front of the A, so A times B has to be equal 6. But also A plus B has to be 7. Luckily, I can already start seeing that 6 times 1 is going to be the thing that gives me 7. I'm only dealing with positives here, so I don't have to worry about any negatives. So let's do what we did in the last one. So 6x squared, right? And then let's just expand out this 7x to what we have over here. So that's going to be plus 6x plus x, right? And then we still have the plus 1 on the end. Okay, now let's group. Well, I think I already have it set up in a way that I can group this, right? So with this first term, I can pull out 6x, and I'm left with x plus 1. And then in this last term, I just have what? I can factor out a 1. We can show it like that, right? X plus 1, just so we can show that. So now, hopefully you can see that I can break this up into x plus 1 times what? 6x plus 1. And then if we check that, we would end up with 6x squared plus 6x plus x plus 1, which is what we want it to be. Okay, so I want to show you basically how we did this with the A and the B's if you are a person that likes to use that as well. So let's say I'm going to use this because this is what I saw in a video. So basically if you have two factored points that are like this, so some number f times x plus another number g, some number h times x plus another number j, if you're trying to figure out the pattern of that, let's multiply this out. We'd have f times h x squared, right? Then f times j plus f times j x, then plus g times hx. So here's our variables, right? And then plus gj if we expand it out. So what happens is this is fhx squared, and then just like we could factor out the a and the b when it was simpler, this ends up being fj plus gh times x plus gj, right? So really this is the same as that a and the b in that first example, just when you're figuring out this middle term now, you have to think it's a product of this first number and this last number plus the product of this and that. So that's why it gets a little bit more complicated in the middle. This is confusing, you can ignore it. It's really a bunch of trial and error. It's okay if you mess up here. Let's say you get it wrong. for some reason with some arithmetic or the numbers you chose, you can always go back and choose more and check if you got it correct, okay? So we're going to keep factoring, and then you guys let me know if we need more practice, and we'll pause and do a couple more days of this. Bye.